Okie dokie. So, welcome to another episode of Passing the Common Core Algebra course subject, and of course, the regents, which is the important part, right? We're going to be looking at properties of real numbers. All right, the first property that we're going to be looking into is the commutative property. All right? Okay, the commutative property. Simple. It says that it doesn't matter how you add the numbers, the result will be the same. For example, by the way, in every property except for one, we're going to have property of addition and property of multiplication. So for example, the commutative, okay, let's call it the CPA. Commutative property of addition says that A plus B is equal to B plus A. What? Yo, son, I mean, can you like at least put it in numbers so I can understand? Okay, cool. So, yes. In other words, give me a number for A. Let's say A is 2. 2 plus 3 is the same thing as 3 plus 2. See? A is 2, B is 3. So 2 plus 3 is what? 5, right? And what is 3 plus 2? 5. The same thing, okay, happens. Now, it does not work for subtraction. 2 minus 3 is not the same thing as 3 minus 2. 2 minus 3 is negative 1, and 3 minus 2 is 1. So no, it don't work. It only works for addition. Even if you're putting negative numbers in here. Negative 2, okay, plus 3 is the same thing as 3 plus negative 2. Yes, when you're using the addition, and you will see that it's the same. Alright, now that is the CPA, the commutative property for addition. How about the CPM? Guess what it means? Commutative property of multiplication. We already established this number, so those are the ones that I'm going to be using. Look, 2 times 3 is the same thing as 3 times 2, which is what? 6, right? Now, if you wanted in variables, letters, you could write. And yes, it's a nice idea if you write it down, if you take notes, okay? Taking notes is one of the most important parts. So, A times B is the same thing as, right, B times A. That's basically what the commutative property says. The order doesn't matter. You could switch them around and it doesn't matter. Now, does it work for division? Of course not. 3 divided by 2 is not the same thing as 2 divided by 3. Duh! Alright, next we are going to be talking about the associative property of addition and then multiplication. So, associative property. How do you write associative? Associative property. It says, given at least 3 numbers, A, B, and C, it doesn't matter how you group the numbers, the result will be the same. For example, A plus B plus C should be the same as A plus B plus C. Son, can you give me a numerical example because I don't understand this crap right here? No problem. I'll do it. So A, we established that it was 2 plus B, we established that it was 3. Now we got a new member here, so let's give it the value of 4. This should be the same thing as 4. I know you're used to parentheses being a sign of multiplication, but it's not. If you have a plus or a minus between a number and the parentheses, it's just grouping, it's not multiplication. Just keep that in mind, don't get confused. So let's see. 2 plus 7 is 9, right? And 5 plus 4 is 9. So it holds true. Now this was the associative property of what? Guess, take a wild guess. Yes, of addition. So let's move on to the associative property for multiplication. Associative property of multiplication. It says exactly the same thing. A times B times C is the same thing as A times B times C. Oh my God, I made a mistake. The parenthesis doesn't go here. This is supposed to be an asterisk. Okay, because I'm trying to use the associative property. I could have put parentheses, but that's not the purpose of this lesson. So in other words, 2 times 3 times 4 should be the same thing as 2 times 3 times 4. 2 times, okay, 3 times 4 is 12, so 2 times 12 is 24. 2 times 3 is 6, times 4, 24, same thing. So that covers the commutative property and the associative property. The difference between the commutative property and the associative property is that in the commutative property, the terms can be swapped, okay? They can change, switch places. In the associative property, look, they have to be kept the same. Look, A, B, C, A, B, C. A, B, C, A, B, C. They have to be kept the same. The only thing that changes is the grouping of the terms. That's it. Alright? Cool then. Let us look at a different property. Now you should be taking notes if you know what's good for you. And for you, and for you. Let's take a look at another important property here. This is one of the most important properties, and it's going to be in blue. We're talking about the DP. This is the only property that doesn't have a distributive property for addition and a distributive property for multiplication, because this is the only property that combines addition, right, and multiplication. So it is said that the distributive property, okay, distributes, okay, multiplication over addition. What? Easy. It will always look like this. So that's enough. A times B plus C. You see, there is no plus or minus. That means that you're multiplying straight right here. Okay, straight through. So how do we multiply using the distributive? Well, distributive means you distribute. So look at this. A is gonna get multiplied by B. A times B is AB. A letter times a letter, put the two letters together if they're different, and that's it. Now look, is this term positive or negative? Positive. And then this is positive, so with a positive here. And then look, we move on to the next term. So we have A times C is AC. Something very important for the algebra. When you use the distributive property, every single term gets multiplied by everything else. In other words, everything times everything. I'm going to show you. Okay, let's have another example. You want to use, let me give you a different example so we understand what the distributive property is all about. Let's have the number 3 times the variable x plus 8. Okay, so let's start distributing. 3 times x, a number times a letter is the number and the letter. 3 positive times positive, positive. 3 times 8, 24. So my final answer is 3x plus 24. What in the world does that mean? Right now it don't mean jack. Seriously, it don't mean anything. But that's the way you do it. In the future, when we start solving real world problems, then it will mean something. Let me give you another example. Three times x plus 2y minus b is the same thing as, and then we use the distributive property, which we multiply everything outside the parentheses times everything inside the parentheses. So 3 times x is 3x. Positive times positive, positive. 3 times 2y, you multiply the coefficients. 3 times 2 is 6. There's no letter here, but there is here, so that's 6y. And then positive times negative is negative. 3 times b is 3b. Hope you could see this. Okay? So that is all about the distributive property that you need to know for now. Later we're going to start using binomials and all that stuff, but okay. So there's a couple of other properties that you need to be familiar with. One is the identity property. Okay? So identity properties. The additive identity, okay? Additive identity. The additive identity is the number 1. You're not correcting me? If you corrected me, that means that you know. If you don't, then I'm going to tell you something right now. That is not the additive identity. Why? Because the additive identity is that number that when added to another number, you get the original number. Like for example, 3 plus what is 3? Correct, that number is 0. 0 is the additive identity. Why? Because anything plus 0 is itself. Beker plus 0 is Beker. Joanne plus 0 is Joanne. Carlos plus 0 is Carlos. Table plus 0 is table because you're adding nothing to it. Got it? So 0 is the additive identity. Now let's go with the multiplicative identity, or the identity element of multiplication. So let me see, multiplicative. Let me put it in red so you understand the difference. Multiplicative identity. That is that number that when multiplied by some other number gives you the original number. Maybe I'm saying it wrong. Maybe I should provide mathematical evidence for this. The multiplicative identity. When a number is multiplied by that identity, you get the original number. So for example, you have the number 3 times a number, I get 3. What is that number? 3 times what is 3? Nice, yes. 1. 3 times 1 is 3. 4 times 1 is 4. 0 times 1 is 0. So 1 is the identity element of multiplication. Anything times 1 is itself. So let's take a look at the last couple of properties. There is a property called closure. Okay? You could say that the rational numbers are closed under addition or under multiplication. What? Okay, let's talk about this. The real numbers are closed under the operation of addition. Meaning what? Well, if you have a real number or any number, right? And you add. If you add two numbers, will you get another number? Yes. So it is closed under addition. When you multiply a number times another, do you get a number? Yes. So you're saying that they are closed under multiplication. That's basically what it is, closure. Okay. There are some exceptions. Like for example, when you divide, okay, addition, multiplication is good. But division, if I want to divide, let's say I want to divide 3 by 0. If you divide 3 by 0, you're gonna get an error on the calculator, which is basically undefined. And if you ask Siri about it, Siri is gonna tell you, oh, please do not make me divide by 0. That would be like me asking you to grow a third arm, which you cannot do, right? So you cannot divide by 0. Now, do not confuse 3 divided by 0 with 0 divided by 3. 0 divided by 3 is 0. Example, if you have no friends, 0 friends, and you have 3 cookies, and you're supposed to divide the cookies between your friends, how many cookies each friend gets? Wait, you got no friends. Poor thing, sad. But if you have 0 divided by 3, you got no cookies, but you got 3 friends. How many cookies each friend? 0, because you got no cookies. Okay, so that's closure. Another one is the additive inverse. Additive inverse. The additive inverse of a number is the opposite. The additive inverse of -3 is +3. The additive inverse of -4 is +4. The additive inverse of 10 is -10. The additive inverse of 0.5 is -0.5. The additive inverse of 1/3 will be -1/3. Now, why is that additive inverse? Well, something to keep in mind forever, and you better listen to this part. When you use the additive inverse on a number, means the opposite, then you are going to, it's like going backwards from the identity element. Oh, previous page, sorry. When you use the additive inverse, the operation that occurs and the result that you will get is the identity element of addition. Look, -4 plus 4 is 0. 10 minus 10 is 0. 0.5 minus 0.5 is, yes, you got it. You're awesome. Not really, I'm awesome. Okay, 1/3 minus 1/3, 0. So that's the additive inverse. Now let's go on to the next property, which is called the multiplicative inverse, okay? Let me do it in blue. Multiplicative inverse. So it is AKA, also known as the reciprocal of a number. For example, The reciprocal of 3 over 4 is 4 over 3. Flip the fraction. So the same way the additive inverse works with the results is the same thing for the multiplicative inverse or reciprocal. Look. If you multiply this, you're gonna get 12 over 12, which is 1, because 12 divided by 12 is 1. And 1, we know that is the identity element of multiplication. Now guess what? If these 3 over 4 had been negative, then the reciprocal would not be 4 over 3. It would have been negative 4 over 3. It doesn't matter where I put it, on top or in the bottom, you're still gonna get the same. Why? Because negative times negative is positive. Yes, this negative means that the whole fraction is negative. Now, for a fraction to be negative, you can have two combinations, positive over negative or negative over positive. That's what makes the fraction negative. So then, what we do is, we just put a negative. We put a negative just in the middle, between the numerator and the denominator. Okay? So, once again, I only gave you one example, let me give you another one. How about the multiplicative inverse of 1 over 2? Yes, that would be 2 over 1. Because when you multiply, you're going to get 2. When you multiply, you're going to get 2 over 2, which is 1. Okay, but then what is the multiplicative inverse of 10? Hello? 2 over 1 is the same as 2, right? So if I was to ask you, what is the multiplicative inverse of 2? You would say 1 over 2. Because 2 is the same thing as 2 over 1. So if I ask you for the multiplicative inverse of 10, you could say that this is 10 over 1. So then the multiplicative inverse would be 1 over 10. Oh, Bex, that's what you meant, son. You're the best. No, I am not from there. So this is 10 over 10, which is 1. Uno. Alright? So that takes care. Additive inverse, multiplicative inverse, closure. That means that when you combine any two numbers, you get a number. Like the dumbest, I guess, property of all. Let me see. We have distributive property. Trichotomy. Should I do trichotomy? I don't know. Let me see now. Oh, okay, fine. We forgot one more. I didn't want to waste this paper on this property, but I'm just gonna do it. So we have two more. We have two more properties. Let me see if I can do it. So we have the law of, I hope I spell it right. Let's see now. The law of trichotomy. Trichotomy or trichotomy or however, I really don't even know how to read that. It says that when you have a comparison between two numbers, only one of three things can happen. Either the number is greater than the other, or the number is less than the other, or the number is equal to the other number. I know. Caught you, even if you don't want to, because I caught you. Alright, what is the other law? Density. Law of density, density property, I don't know. Anyway, all of these are also properties of equality. Equality means one equals to the other, like not quantity, but one side equals to the other side. So anyways, density. Density says that on the number line, you have numbers, right? Duh, what else are you gonna have? Sure. 0, 1, 2, -1, -2. It says, how many numbers do you think exist between 1 and 2? Well, how many numbers are there altogether? Infinite, right? and negative infinity. How many numbers do you have between 1 and 2? I can start with 1.000000001, right? And then 1.0000002, right? And then 1. Oh my God, we're never gonna end. Guess what? Between like around here, you have the square root of 2. Here you have the square root of 3 or 4, so on and so forth, and so on. There are infinite many numbers between each given interval. So that's what the density property says, that there's infinite many numbers between any two given numbers. Imagine if I was to ask you how many numbers are between 0.1 and 0.2. Still 0.1000001, 0.1000002. So forget it. It's like that. So that is the law of density. Okay? Anything else that I need to go over? Let me see. Okay, let's see now. Adding 0 to a number leaves it unchanged. What property is that? Additive identity. Multiplying something by 1 leaves the number unchanged. What property is that? Multiplicative identity, or identity element of multiplication. Okay? When two numbers are added, the sum is the same regardless of the order. Well, you go back to that and you will notice that it's the commutative property. The product of any number and 1 is that number. Identity. What else? I don't know. I mean, so many. But I think that with these examples, you'll be okay. Like for example, if on the regents they're asking you, for example, you have 2x plus 9 equal 16 plus 1x, and all of a sudden they show you this 2x equals 7 plus x, and they ask you what property was used here. Well, you could say that the additive, well, you could say additive inverse, because I noticed that they subtracted 9 from here. Okay, so you could say it was the additive inverse was used over here, additive inverse, or addition property of equality. What? Yeah, addition property of equality, meaning what? That when you did something to this side, you had to do it to the other side of the equal sign, equality. So additive property of equality, or they use the additive inverse. You have to be careful, like how they do it. Look, they subtracted 9 from both sides. So 16 minus 9 is 7. Okay, so learning intention number 5, and we're going to be looking at the laws of exponents, and also we're going to be reviewing some like terms. So let's see. First, we got these 3 examples, and we are going to identify the coefficient, the base, and the exponent. Here, my friends, the coefficient is the numerical value, which is 2. The base is the number that is being raised to the whatever exponent. So the base is 2. Whoa, hold, Bex. Like, the base and the coefficient are the same? Yeah. Exponent is the little number on top of it's like your conscious. Like, yes. Is this little 3 right here. Okay? With that in mind, let's move on to the next one. 2x to the third power, if we want to say, but in reality is 2x raised to the exponent of 3. Okay? Why? Well, because the power is actually the whole thing. 2x to the third is that. The power is 2x to the third. Anyways, forget about that. You can still use it. So the coefficient here will be the numerical value. Okay, we're good with that. Now the base, remember, the base is what is being raised to. No, sorry. The base is the number that is going to be raised to the whatever exponent. So in here, the base becomes x. And the exponent becomes 3. In this example, and by the way, like 90% of the time, the base will be some type of variable. So in this case, the coefficient is the numerical value for the base is nothing more than x, y. Exponent, well, in this case we have a 2 and we have an exponent of 5. Okay? So enough with that. Let us take a look at like terms. What are like terms? Like terms are terms that have the same variable, okay, and they must have the same exponent. Good, you're taking notes. Okay, so now let's take a look at some examples of like terms. For example, if you have, okay, example number 1. If you have 2 apples and then you pick up 3 more apples, you end up with 5 apples. See that? Now, let's say, example number 2. Let's say you have 2 apples and you pick up 3 more apples that are rotten. So let's put an R over here for rotten apples. It could have been a 2, a numerical value, it really doesn't matter, but I just want to make the point. Look, when you add this, you're going to end up with 2 apples and 3 rotten apples. Why? Well, no, you're not going to combine the good apples with the bad apples because you're not going to have bad apple or grad apples. No, you have 2 good apples and 3 rotten apples. That's it. It's like if you have an orange and a pineapple. What do you have? An orange and a pineapple. You don't have a pat orange or whatever you want to call it. Another example of like terms, okay? This time we're gonna use x. So 2x plus 3x plus 6x to the second power. What is this equal to? Well, 2x's, same variable? Yes. Yes. Same exponent? Yes. Yes. No. By the way, whenever you don't see a number, an exponent is always a 1, just in case. So 2x to the first plus 3x to the first. 2x's plus 3x's, 5x's. So you have 5x plus 6x squared. 6x squared. This, I was not able to combine this with them because unfortunately it does have the same the same variable, but the exponent is not the same. Another example. If I ask you what is 3x plus 9, please don't tell me it's 12x. Please don't tell me it's 12. Please don't even think about it. Variable, no variable. No variable. So then this is nothing more than 3x plus 9. If it was a minus, then 3x minus 9. As simple as that. So that's how you play with like terms. Right? So I hope you copy that. You have your notes. Remember, your notes are the most important tool for you to study. Okay, now that we have that out of the way, let us go over properties of exponents. Alright, so the first one that we're going to do is the product rule. Product rule. Okay? Eat Kobe. What are you doing? Do not eat anything. Hey, hey. Okay, goodbye. Alright, so where were we? Oh yeah, product rule. It says that if you have, let me change the color here. It says that if you have a number raised to a certain power multiplied by another number to another power, okay, then the result will be that base, you copy the base, raised to the sum of the exponents. That's what it is. Now let me give you an example. Example number 1. If you have 2 to the third power multiplied by 2 to the fourth power, you're gonna end up with, you're not gonna multiply 2 times 2 and it's not gonna give you 4. No. 2 to the third power times 2 to the fourth power is 2 to the seventh power. What? Chillax. I'm gonna explain to you. Look. 2 to the third power is nothing more than 2 times 2 times 2. 2 to the fourth power is 1, 2, 3, 4. This dot in the middle means multiplication, okay? So now let's see what we have. We have this times this. So we have 2 times 2 times 2 times 2 times 2 times 2 times 2. And remember what the exponent does. The exponent is the amount of times the base is going to be multiplied by itself. So this is 1, 2, 3, 4, 5, 6, 7. So therefore, 2 to the third times 2 to the fourth is 2 to the seventh. This is called the proof. When they ask you for mathematical evidence, boom, that's what you do. And it works for everything, okay? Okay, do we have another example? No. Alright, so enough with this. Now let's have the quotient rule. Oh, by the way, so in other words, when you multiply powers of the same base, you add the exponent and you keep the base. So now the quotient rule. Or the quotient law, whichever you want to call it. Rule, law. A rule is something that you follow. The law is something that you follow. Rules were meant to be broken. The law, I don't know if it was meant to be broken, but Okay, so we have the following. It says that if you are dividing x to the m by x to the n, and you know what? You don't even have to think that much about it. Look at this. The product rule says that when you multiply powers of the same base, you keep the base and you add the exponents. That's multiplication. You add the exponents. So in quotient, which is another fancy word for division, when you have a division, guess what you're gonna do? You're going to subtract. So the proof is the following. Let's have the same example. No, you want to have the same example? No, you don't want to have the same example. Let's see if I have another one. Example number 1. 3 to the fourth power divided by 3 to the second power. Okay? So this is the same thing as 3 to the 4 minus 2, which is 3 to the second power. The proof in here is the following. 3 to the fourth is 3 times 3 times 3 times 3 over 3 to the second power is 3 times 3. See that? Expanding is always a good way to prove things. So let's see now. This is division. A fraction means division. So 3 divided by 3 is 1, because a number divided by itself is 1. Times 3 divided by 3 is 1. Okay? So you end up with 1 in the bottom because you run out of numbers. And look, here you end up with 3 times 3 is 3 to the second power based on the product rule. Look, the exponent here is 1 and 1. So when you multiply powers of the same base, you add the exponents. Nice. Okay. One of my students told me, what was it? Oh yeah, why did Simba's dad die? Cause let me see. Cause he didn't move fast enough. He didn't move fast enough. Something like that. I don't know. Anyway, it's like why the chicken crossed the road. Alright, next rule. We're gonna have an exponent of an exponent. So let's use the black marker right here. Okay? Raising an exponent. Raising an exponent to an exponent. What? Easy. Let me see if I have an example. Well, the rule says the following. If you have a number raised to the power of m. Oh wow, sorry, gotta take this. Sorry, gotta take this. Hello? What's up? Sí, pero dime. No, vos decidí. Vaya pues. Alright, you see I can multitask. I answer the phone and I'm still writing the rule. So it says that when you raise a power to another, raise an exponent to another exponent, all you have to do is multiply the exponents. So in other words, that's the rule. Yeah, Bex, but like, okay, I get it, I understand like how to do it, but can you prove to me that that's really what it is? Sure. Look, example number 1, right? You see, do we have time? Yes. Example number 1. Let's say you have x to the third power raised to the raised to the fourth power. Well, think about it this way. If you have x to the fourth power, that is the same thing as x times x times x times x, correct? Because that's x to the fourth power. Well, here I'm saying whatever is in parentheses, I'm raising to the fourth power. So in other words, this is the same thing. Remember, I'm raising to the fourth power, so this is the same thing as x to the third, okay, times x to the third times x to the third times x to the third. See? 1, 2, 3, 4 times I have what's in parentheses. If we go back to the product rule or law right here, it says that when you multiply powers of the same base, you copy the base and you add the exponents. 3, 6, 9, 12. X to the 12th power. Now let us not use the product rule, let us not expand, and let us just do it straightforward. So notice what you have here, a 3 and a 4. So what would be a shortcut to raise an exponent to another exponent? Well, I got a 12. How do I get 12 from here? Exactly, multiply the exponents. So then, x to the third to the fourth is nothing more than x to the 3 times 4, which is x to the 12. Alright? Alright, let's look at another law. Any number, let me see, can I right here? Okay. Any number, okay, 0 exponent. zero exponent law if you want. Okay, hopefully you can see this. So look, it says that any number raised to the 0 power is equal to 1. What? Yeah, any number raised to the 0 power is 1. So how does that work? Oops, sorry. Okay, right here. Well, let's create an example based on the quotient rule. So let's say I have, really, Kobe, listen, I don't want to hit you. What's wrong with you? No, you're not eating the marker. Go away. Thank you. Bye. Okay, so let's say I have 3 to the fourth power divided by 3 to the fourth power. Not 34, to the fourth power, or to the exponent of 4. So if I follow the quotient rule, this one, I have to subtract the exponents, so I get 3 to the 0. Now let me prove this to you. 3 to the fourth power. No, Kobe! Don't eat the cable. 3 to the what? Oh yeah, 3 to the fourth power is 3 times 3 times 3 times 3. Divided by 3 to the fourth power is 3 times 3 times 3 times 3. Okay, now I have expanded it. Now watch. 3 divided by 3 times 3 divided by 3 times 3 divided by 3 times 3 divided by 3. Yeah, I know, we get it, Bex. Like, come on, we're not that. You understand what I'm saying? I know, I'm just. So look, hey. So look, 1 times 1 times 1 times 1 is 1. So it is true that any number raised to the power of 0 is 1. But then again, why? Well, think. Any number divided by itself is 1. And look at this, 3 to the 4th divided by 3 to the 4th. They're the same number. So that's why it's 1. So, definition, any number raised to the power of 0, any number raised to an exponent of 0 will equal 1. Alright, I think I'm heading towards my last property, and then we're gonna do some problems, some nice exercises. If, I'm running out of paper, maybe I'm gonna have to do this in a different video. Okay. Negative exponents. Negative Alright, negative exponents. So, what happens when you have something like, no, first let us actually give you the definition. Or not definition, but like the practice. Look, if you have 3 to the negative 2, this is the same as 1 over 3 to the positive 2. If you have x to the negative 5, this is the same thing as 1 over x to the 5th. If you have 10 to the, Jesus Christ, to the negative 7, this is the same thing as 1 over 10 to the 7th. So, facts, right? Facts. So now, explanation. Sure. When can I get a negative exponent? Well, the quotient rule. For example, let's divide something. Let's say I have, I don't know, oh my God, 4 to the 3rd divided by 4 to the fifth power. Okay? So if we follow the quotient rule, we know that we have to subtract the exponents. So we have 4 to the negative 2. So how do we prove that 4 to the negative 2 is the same thing as 1 over 4 to the second? Well, let us expand. That's how we prove, that's how we show work. Let us expand. Let me do it in a different color. Let me expand. 4 to the third is nothing more than 4 times 4 times 4. 4 to the fifth is 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. So now, let's see. Let us start eliminating. So 4 divided by 4 is 1 times 4 divided by 4 is 1 times 4 divided by 4 is 1. 1, right? Look, where does the 1 go? Top or bottom? Well, I ran out of 4s on the top. So it's 1. And what do I have left in the bottom? 4 times 4, which is 4 squared. Thus, I have proven that a negative exponent is the same thing as the reciprocal, but to the positive exponent. Cool? Alright, so let us start doing some problems, I hope. Let's see. For example, on the independent practice. So we're going to start with the independent practice. Independent practice. So I said, what is the product of negative? So the first exercise is negative 3x squared y times 5xy squared plus xy. Okay, here I have a typical example of the distributive property. One number, no sign, so times an addition of two other numbers. So to use the distributive property, remember you must multiply everything by everything. Got it? Good. La propiedad distributiva se multiplica todo por todo. So I'm going to start. So I'm going to take this number and I'm going to multiply by this number. So when you do multiply that, make sure that you multiply the coefficients, the base, and do the appropriate work with the exponents. So let's see now. Negative times positive is negative, right? So this will be negative 3 times 5 is 15. So negative 15 x squared times x. Now this is an x to the first power if you don't see the 1. So x squared times x to the first power is x to the third power. Y times y squared, this is a y to the first power as well. So y times y squared is y to the third. Negative times positive. Okay, look, I multiply by this one, now I'm going to multiply by this one. So negative times positive is negative. And I don't think it's going to fit, but I'm going to try. So there is no number here. That means that this is an invisible one. So negative 3 times 1 is negative 3. X to the first power times x to the second power, that's x to the third power. And then y to the first times y to the first is, oh my god, y squared. Okay, next to the x to the third power. I'm sorry, didn't fit. Should have written smaller, right? So that takes care of the first problem. Let's go on to the second one. It says 12x to the third 12x to the third minus 6x squared plus 2x divided by 2x. Okay. Listen to me. When you have an expression that has addition and subtraction and you're dividing by a single number or 2x, right? Everything gets divided by that number. In other words, you could rewrite this as 12x to the third divided by 2x minus 6x squared divided by 2x plus 2x divided by 2x. Okay? So let's think about it. Let's think it like that. So let's start. 12 divided by 2, 6. X to the third divided by x to the first. Remember what you do when you divide powers? You subtract the exponents. So 3 minus 1, because there's an invisible one here, is 2. Minus, why minus? Because negative divided by positive is negative. Minus, and then again, 6 divided by 2, 3. X squared divided by x to the first is x to the 2 minus 1. So that's x to the first. And then plus, divided by plus is plus. So plus 2x divided by 2x is a number divided by itself. Remember, this will be what? X to the 0 power, right? Which is 1. Or 2x divided by 2x. When you divide a number by itself, it's 1. And that would be the answer to that second problem. Third problem. 3x squared y to the fourth okay, times 4xy squared. 4xy squared. Well, one number. This is not 1, 2, 3 numbers. This is just one number. And this is just one number. If there was a plus or minus between them, that would make it more than one. But everything here is together. So let's see. Let's multiply. 3 times 4, 12. X squared times x to the first is what? X. If you are confused, you go back to the product rule. So x squared times x to the first, x to the third, and then y to the fourth times y to the second is y to the sixth. So that's it. That's what you got. Okay. And I need more paper. Okay. Let us do one last exercise on this session because I'm not gonna be done. Okay, it says 45 a to the fourth b to the 3. So 45 a to the fourth b to the third minus 90 a to the third b divided by 15a to the second b. Okay. So once again, here is not one number, it's two numbers. Look, this one and this one because they divided by a minus sign. Alright, so how do I tackle this problem? Well, remember, coefficients will be divided. Bases, exponents will be subtracted. So let's see, 45, and remember, is this divided by that and this also divided by that. So let's see now, 45 divided by 15 is 3. A to the 4 divided by a squared is a to the 4 minus 2. So that is a squared. The bell just rang. Now b to the third divided by b to the first is b squared. Okay, 3 minus 1 is 2. minus 90 divided by 15 is what? 6. 6. A to the third divided by a squared is a to the first. Because 3 minus 2 is 1. And then b divided by b is 1. And remember, this is one number. So b divided by b, there is no addition or subtraction. So there is times 1. Oh my god, my dog just went crazy. Kobe. No. Okay. So 6a times 1 is 6a. You see what I gotta go through? Alright, so then at the end, my answer would be 3a squared b squared minus 6a, because 6a times 1 is 6a. Got it? So that's it. Alright, so I'm gonna stop right now because I need more paper, because as you can see, I kind of like run out of paper. And I'm gonna continue with this lesson number 5 later. Okay, let's do another exercise, another problem, okay? So I'm gonna use blue ink. Alright, so the next problem, okay? It says, what is 3 to the 4th, 3 to the 3rd times 3 to the 4th? Well, using the product rule, we know that this is 3 to the 7. I'm not gonna prove it, but I'm gonna tell you how to prove it. 3 to the 3rd is 3 times 3 times 3. And then 3 to the 4th is 3 times 3 times 3 times 3. So just, you could expand it right here, and you will see that you will have 7, you will have 3 multiplied by itself 7 times. So that's why it's 3 to the 7. Next, it says express in exponential form with base 4. Okay. How can I express 16 as something like 4 to the something power? 4 times 4 is 16, so it's 4 to the second power. B, how can I express 64 as 4 to the something power? So 4 to the something power, let's see. 4 times 4 is 16, times 4 is 16. Oh my god, yes! 4 to the 3rd power. See? Yeah. Alright, so 4 to the 3rd power. Okay, so we're done with that. Alright, 27x to the 18. Oh my god. Okay. So we have this exercise right here that it says 27 to the 18th power, y to the 5th, okay, over 9x to the 6th, y. So, how can I express that? Well, first we deal with the coefficients. 27 divided by 9 is 3. And the 3 goes on top because this is the larger number. Got it? Okay. That was funny because it says 27x to the 18th. X is raised to the 18th. I'm sorry I made the mistake, but x is raised to the 18th. So x to the 18th divided by x to the 6th. Remember, it's like saying x times x times x times 18 times. So then what do I have? 18 minus 6 is 12. And then y to the 5th divided by y to the 1st, because there was no number there. That's y to the 4th, and that's the end of it. Simple, right? Remember, try to work these problems out before we do it. Before I do it, before you do it. Okay, next problem. Oh, by the way, each of these problems has why. Well, why means explain. So what you can say is the following. Well, we know that when we divide coefficients, okay, we just divide them. So 27 divided by 9 is 3. And then when you divide powers of the same base, we have to subtract. So x to the 18th divided by x to the 6 is 18 minus 6 is 12. And then 5 minus 1 is 4. And that's it. Okay. Next one. Negative 14a to the second c to the 8th. So negative 14a to the second c to the 8th divided by okay, divided by 7a to the third c to the second. Alright, so the whole thing is going to be negative anyways. So it's going to be negative. Okay, 14 divided by 7 is 2. A to the second divided by a to the third is a to the negative 1. Remember, the quotient rule says that you gotta subtract. So 2 minus 3 is negative 1. C to the 8 divided by c to the second is c to the 6. Now, the moment that you've been waiting for. How can I rewrite this? Well, negative 2 is multiplying a to the negative 1. So it's going to be negative 2 times a to the negative 1. We already agree and we understood why it was a to the positive 1 times c to the 6. Remember, this is a multiplication. Negative 2 times the variable a to the negative 1 times the variable c to the 6th power. Okay then. And we understand why this is 1 over a to the first. So when we multiply, we get like negative 2 times 1 is negative 2 times c to the 6. But now over what? Well, this is over 1 and this is over 1. So 1 times a is 8 times 1 is 8. And that's what you get. Okay. Next problem. What is 3x to the second? That's to the second. I know it looks weird. 3x to the second to the third. Now I'm raising an exponent to another exponent. So basically, oh, by the way, this means do whatever is inside the parentheses 3 times. So I'm only gonna do this one time. I'm only gonna show you and hopefully you understand one time. Whatever is inside the parentheses gets raised to the third power. So this is nothing more than 3a to the second times 3a to the second times 3a to the second. So 3 times 3 times 3 is 27. A to the second, a to the second, a to the second, that's a to the 6th. Got it? Or I could just done the following. 3 to the third power is 27. 8 to the second to the third, well, 2 times 3 is 6. So, nice. Nice. Alright, so, and basically that's what you have. Alright, so let's move on to the next problem. If I can just separate these pages because these pages are kind of like sticky. Okay. So, next problem. So that is 2x to the third times 8x to the 5th divided by 4x to the 6th. Okay, so there is no sign like plus or minus, so basically you don't have to divide this by this and this by this. No, this is a multiplication. So let me multiply the top to make it easier. So 2 times 8 is 16. X to the 3rd, x to the 5th, x to the 8th, divided by 4x to the 6th. Okay. 16 divided by 4 is 4. 8, x to the 8 and x to the 6. That's x squared. Okay. Look, next problem. We have 3x squared. Let me see. 3x squared. Did we do that? Yeah, we did that. We have the next problem. 12w to the 9 y to the 3rd divided by 3w to the 3rd, sorry, divided by negative 3w to the 3rd and y to the 3rd. I know this is boring. I know, well, classes are boring. There's nothing we can do, sorry. Oh, I need some water. Okay, so let's see. 12 divided, positive divided by negative is negative. 12 divided by 3 is 4 on top. W9, W3, that's W6. And Y3, Y3, that's 1. How do I know that? Because y to the 3rd divided by y to the 3rd, they're the same number. A number divided by itself is 1. Okay. You know what? You are killing me. Again, bye. Okay, you wanna do this? Anyway, Kobe. So now this is the same thing as negative 4w to the 6. That's basically what it is. Okay, next exercise. Kobe? See, I told you markers. These markers are awesome. They get you like... Alright, so now we're done.